Right, carry on with solving equations. That's section 12.4. I'm working on page 138, looking at question 17. Now, some of these questions will involve forming a quadratic, then solving it, and then the question will be set in a bit of a context. So let's go with question 17. It's a bit of a raw, uninspiring one. Here's an equation. I'm given x squared plus 2x minus p equals 0. Right, so I don't know x's or p's, so I'm in trouble. I'm told one solution is x equals minus 5, so I've got to somehow work backwards and find p. Fair enough. Okay, well, basic grade B quadratic, because there's nothing in front of the x squared. I know one of the answers is minus 5, so within this bracket it must be x plus 5, and x times x makes x squared, and the trick is 5 times something is going to make this mystery number minus p, or just p then. And well, in order to get 2 x's, I've got to have minus 3 at the end. Let's just multiply this out to be sure. Right, that little bit is x squared, you know that, don't you? And x times minus 3 is minus 3x. This is me testing out my ideas. 5 times x plus 5x, and 5 times minus 3 is minus 15. And look, minus 3x plus 5x is 2x, so he's very happy. And by comparing, I've got p equals 15. Is that alright? Everything else is accounted for. The x squared is done. And just to highlight it a little bit, I can see that minus p is minus 15. And conclusion, p is 15. I think 18 is a similar sort of arrangement there. I've got the equation y squared plus qy, in other words, something times y, minus 12 equals 0. I'm told one solution is y is 3. In other words, double brackets equals 3. Oops, no, not. What I mean is the y equals 3, the whole quadratic is equal to 0. Right, I've got y there and a y there. To make a solution of y equals 3, I need minus 3 right there. Now, minus 3 times, this is, in fact, it's easier than question 17. This is question 18. Minus 3 times something makes minus 12. It's got to be plus 4, hasn't it? Dead easy. Minus 3 times 4, minus 12. Now, if I multiply out, I need to see what happens in front of that y there in the middle. Bust it open. There you go. Y squared plus 4y. That's going to be minus 3y. And there's the minus 12 I told you about. Simplifying, I've got y squared plus a single y, because 4y take away 3y is 1y. Take away 12 equals 0. I'm not asked to solve it, I'm just asked to work out the value of q. Well, by comparison, I have got qy and y, in other words, a single 1y. Conclusion, q equals 1. Finished, that's all there is to it. Now, it's going to get dangerous now, from what I can see. Right, this is the kind of question there's loads of in the other book, and the old scheme. I'll draw you the picture they've got. I've got a rectangle like that, drawn better than that, of course, and I've got a little corner off that being chopped off. That's 6 across there, and that's 4 across there. All numbers are in centimetres. I'm told the height of this rectangle, or the width, is going to be x minus 5 centimetres, and the length is x. In other words, that's x. X minus 5 is obviously shorter than x. Right, the length of the rectangle PQRS, I'm not even going to go through all these letters anyway. This is the shaded area, all this little bit in here. So this is the stuff that's relevant to the question. And I'm also told that this shaded area has a certain value. So an arrow down there, and the shaded area comes to, I haven't got a clue, 164 centimeters squared. Now I'm told, show that the shaded area is x squared minus 5x minus 12 centimeters. Now, this is what happens in exams. When they start getting very difficult, what happens is they give you something to work with, because if you can't show that x squared minus 5x minus 12 is in fact the shaded area, by the way it's centimetres squared, if you can't show that, at least you can use it to do the next part of the question and get some marks. So please be very careful how you attempt to show that. You've got to show every single step. Essentially, this is the shaded area, but the whole rectangle has a certain area. Show that the shaded area is all of that. Okay, fine. So what have I got? I've got a whole rectangle. So let's just fully lay it out for the examiner. Area of rectangle. That's not difficult. It's going to be x times x minus 5. Leave it like that for now. That's that bit. Now we know this part is the triangular part. Area of triangle, well, half base times height. Half base times height. Do this in any order you like, and of course that comes to half of 24 is 12. So the shaded area is going to be the area of the whole rectangle, take away that little sandwich in the corner there. In other words, x into x minus 5, take away the 12, and that's that. Now multiplying out, I'm going to get x squared minus 5x minus 12, and I've clearly shown that the shaded area is what they've given me originally in the question. So I've proved it. I've got myself maybe 3 marks or something. Now part B, I've got to form a quadratic equation and solve it to find the length of the rectangle. Now which bit do they call the length? Oh, the length of the rectangle. Yes, so they want the x bit basically. So this part they've called the length. So that's the length, and not that part. That they've called the width. So call that width as well. Right. So I want to work out x. Now I'm told this all comes to 164. So x squared minus 5x minus 12 equals 164. Now form a quadratic. You bring this over next door and you subtract to get it on to get the to get a 0 on the right hand side. So x squared minus 5x. Now minus 12 take away another 164 is minus 176. Looks like a grade B quadratic, but it is. Trouble is, we've got a horrible number there. We're not allowed to use a machine. X times x. Now I did this earlier because I didn't want to sort of waste an awful lot of time trying to do it in front of you. That works out to be 11 and 16. Alright, so I want minus 5, so that's going to have to win, and that's going to be a plus 11 there. So how did I do that? Well, I know 15 times 15 is 225. It's obviously not a square number, the 176. Then I thought to myself, 6 times 6 is 36, so that ends in a 6 there. So I tried 16s and it went in 11 times. So I did play around with it a little bit and got there in the end. A little unkind. Therefore, I've got x equals minus 11 and x equals 16. Now, which is correct? There's 2 answers. Well, you're not going to have a length that's negative, are you? Therefore, let's specify. Correct answer, x equals 16, and you happily discard that minus 11. You still show it as a solution because mathematically it's correct, but x is not minus 11 centimeters long. It is 16 centimeters long, and that's just applying common sense. I fancy doing question 20. It's got a horrible little star by it. It's one of these squiggly. Oh, I don't know. It's horrid. Have a look. The question's easy though. It says a quadratic equation, and it gives it to us, x squared minus 14x plus 49 equals 0, has only one solution. Only one answer? Why is that? So let me just try and see if that's the case. X and x, how do you make 49? 1 and 49, 2 don't go in, 3 don't go in. I know 7 sevens are 49, and a 7 and a 7 will give me 14. A minus times a minus is a plus, that makes plus 49, and if I was to multiply this out, I will get minus 14x's. Don't make me prove it, trust me, do it yourself. Anyway, that equals 0 because it says so, and look, x minus 7 all squared equals 0, and that's called a perfect square because both factors are identical. So I don't know, if say we're looking at 5 times 5, that's a perfect square, it makes us 25. X minus 7 multiplied by x minus 7, well that's a perfect square, so I'm multiplying 2 of the same. Look, x minus 7 squared is 0. That's called a perfect square, and only one factor, therefore only one solution. And let's give it the solution, let's not mess about. X equals 7 and write the word only. There you go, shown it. Write down another quadratic equation that has only one solution. Alright, there's loads. If I start off with something like x plus 5, just for the fun of it, I know that's going to that's got one solution, because x is going to be minus 5. Right, we know that, but it wants the fully expanded and simplified version. So let's just show how we're going to get from this, which we know is true, to where it can be. We just multiply it all out. So we got x squared plus 5x plus u and u, another 5x plus 25 equals 0. Squish that up a little bit. X squared plus 10x plus 25, and there's another perfect square, because it is in fact that bit. Okay, I think I'll try question 21. I'm on a roll, and these are good fun, aren't they? I think I'll try 21. And thinks of a number, squares it. So let's call it n, because it's fun. Thinks of a number, squares it, and then adds twice the original number, plus 2n. The result is 99. I'm scared now. Write down a quadratic equation, I just have, and solve it to find two possible answers. Right, here we go. So I've got n squared plus 2n take away 99 equals 0. What am I doing? Why am I doing this to myself? N times n. Now I've got to do 99. Grief. Well, 333s is not going to give me, is not going to give me 2 n's. Let's think again. 9s, 9 and 11. Yes, 9 and 11 will give me a gap of 2. 9 there, 11 there. I can go anywhere I like, really. Right, 9 and 11. Right, so I've got to make plus 2n. So I want plus 11 and minus 9. Minus 9 plus 11 is 2n's, and minus 9 times 11 is minus 99. Easy. Right, two solutions. N equals 9, you're happy, or n equals minus 11, you're happy. Didn't say that Anne can't think of a negative number. It says write down a quadratic equation and solve it to find the two possible numbers that Anne started with. She could have started with minus 11, or she could have started with minus 9. And that's really, really easy. I'm going to stop there, have a breather, maybe have a cup of tea, and I'll see you in the next little bit.